Okay, class, today we are learning how to solve absolute value equations. So if you were absent or just needed some extra help, go ahead and pause this first and do the warm-up on our sheet, and then come back and we'll go over it. So please pause. Okay, so let's go over 1 and 2 on the warm-up. So number 1 says, if the absolute value of x is 7, what are the possible values of x? And so we know absolute value means the distance from 0. So on like a number line, if I was at 0, I could walk all the way to 7 on the positive direction, and that would be 7. But I could also walk in the negative direction to -7, and the distance would still be 7. And so the answer to this is x could equal 7 or -7. It could be both, okay? Because the absolute value is the distance. And so once the absolute value is isolated, it'll always become positive inside after you do the math, okay? All right, number 2. What values could possibly be when the absolute value of x is equal to -4? Well, this is a tricky one. So in class, a lot of people said, well, what about 4? Well, if I put 4 in, the absolute value of 4 is 4, not -4. So that doesn't work. Well, if I try -4, absolute value of -4 is 4, not -4. So that also doesn't work. And so this is one of those weird rules that anytime you have the absolute value isolated, meaning the bars are alone, and it equals a negative number, that is not possible. And so you will get no solution. Okay? So now we're going to start learning how to actually solve absolute value. There are a few steps that you need to start with. The first step is to isolate the absolute value expression. So what that means is those bars where the absolute value is need to be alone. If there's something next to it being multiplied, you're going to have to divide it to the other side. If there's something next to it being subtracted, you're going to have to add it to the other side and do the inverse operation so that you can isolate those absolute value bars. Once those are isolated, then you're going to create 2 cases. You're going to take the inside of the absolute value and you're going to set it equal to both the negative and the positive value that was on the right side of the equal sign. Then you're going to solve both of those equations for the variable. Once you get those answers, you're going to have 2 answers. You need to check them in the original equation. So you're going to take those 2 answers, you're going to go back, put them into the original equation, and see if they work. If they work, you're good. Those are your 2 solutions. However, every once in a while, a solution is not going to work, and that is called an extraneous solution. So it's a solution that looks like it's going to work, you solved for it, but then when you plugged it back in, it didn't work, okay? So go ahead right now and write in your own words, what are extraneous solutions? Okay, so let's do a couple of practice problems. So let's start with number 3. So the first step is to make sure the absolute value is alone. So in this case, it is. We have the bars all by itself. So then the second step is to create the 2 cases. The easiest way for me to memorize it is drop the bars and write it twice. One with the positive, one with the negative. So drop the bars and write it twice. One of them will be a positive 5, and one of them will be a -5. Now, step 3 is to solve both of these equations. So in this case, we're going to add 9 to both sides. So we get x is 14. Over here, we're also going to add 9 to both sides, but we have 9 minus 5, so x in this case is 4. So looking good. It looks like we have 2 answers. You do need to double check though, because sometimes it'll be tricky and one of these may not work, or maybe both don't work. And so we need to plug it back in. If I plug it back in, I'm going to say 14 minus 9. That does give me 5. The absolute value of 5 is indeed 5. And so this one does work. The second one, I'm going to plug in 4 into the original problem. 4 minus 9 is a negative 5. But then the absolute value of negative 5 is a positive 5. And so 5 does equal 5. And so both of these work. And you have 2 solutions. Go ahead and pause the video and try number 4. Okay, so hopefully you tried number 4. What you did is it already is isolated, the absolute value. So you need to drop the bars and write it twice. One of them for positive, one of them for negative. And then go ahead and solve for your variable. So in this case, you should have gotten negative 2 and negative 5. From there, you need to go back and check it. So I'm going to plug it into the original problem. So in this case, 2 times negative 2 is a negative 4. Negative 4 plus 7 is 3. The absolute value of 3 is 3. Therefore, that one works. So the negative 2 was good. We're also going to test the negative 5. 2 times negative 5 is negative 10. Negative 10 plus 7 is negative 3. But the absolute value of negative 3 is a positive 3. And so 3 equals 3. And so that one works as well. So your answers were negative 2 and negative 5. All right, let's try one where it is not isolated already. So let's go ahead and try number 7. So number 7 here, this 16 is right up against the absolute value. And so that means it is being multiplied. So to get rid of it, we're going to have to divide. If you look at number 5, I'm not going to do number 5, but you'll see it's a little bit different. The 17 is attached with a plus. So in order to get rid of this 17, you would subtract 17 from both sides. Okay? But let's do number 7. Number 7, we're going to divide both sides by 16. And so 16 divided by 16, that goes away. And so we are left with the absolute value of r minus 5 all by itself. And we have a negative 32 divided by 16. That will give me a negative 2. Okay, some of you may notice something, but I'm going to continue with the steps and show you something in a minute. So now we're going to drop the bar and write it twice. So now that the absolute value is all alone, that 16 has been brought over, we can now drop the bars and write it twice. So we're going to have r minus 5 equals negative 2, and r minus 5 equals positive 2. And then go ahead and solve for r. So we're going to add 5 to both sides. So in this case, r is 3. We're going to add 5 to both sides on this one, and so in this case, r is 7. And then we're going to plug it back in and check it. So since we're not doing number 5, I'm going to use this box. So the original problem was 16 on the outside. And then instead of r, let's use 3. 3 minus 5 equals negative 32. All right, so 3 minus 5 is a negative 2. However, the absolute value of negative 2 is positive 2. And then we're going to multiply it by this 16. And so we get 32 equals negative 32. That is not true. And so that means this is an extraneous solution. And so we are going to cross that out. Let's go ahead and try 7. I need to plug it into the original. So 16. And then we're going to have 7 minus the 5 equals negative 32. So inside we have 7 minus 5, which is 2. The absolute value of 2 is 2. Times this 16 is 32. 32 does not equal negative 32, and so this one also does not work. And so this problem had no solutions. Now, I said there was kind of a shortcut to this. If you went back to our warm-up, remember anytime an absolute value is isolated and it equals a negative, it'll be no solution. So in this case, after I divided both sides by 16, then this was isolated. I had my absolute value isolated and it equaled a negative. So right away from this step, after you did step 1, you would have been able to say no solution. Okay. We're not going to do number 8, but I do want to show you in order to get rid of this -2, I want you to make sure to get rid of a denominator, you multiply both sides by the denominator. And so this -2 will cancel with this -2. And then on this side, you get -6 times -2, and so that will turn into a +12. And so now you'll be able to solve it, and it does have a solution. So if you want to pause and try that one, I will upload the answer key to this later so that you can check it. Before I end the video, I want to show one last one that's a little tricky, and that's number 13 on the back of the notes. So number 13 on the back of the notes, step 1, we need to isolate the absolute value. In this case, the absolute value is already isolated. So then the rule is to drop the bars and write it twice. And so if we drop the bars and write it once as it is, and then drop the bars and write once with a negative. Now it's a little tricky though, because on the right side, it does not just have one number. And so when I do a negative, I need to distribute that negative to both pieces. And so this does cause one more step to happen before you can actually solve. So in this case, we'll have 3x minus 9 equals a -x minus 1. This is now your second case. So this is our first case, and this is our second case. Now we can solve for x. On here, I'm going to subtract x from both sides. I'll have 2x minus 9 equals 1. Add 9 to both sides. Divide both sides by 2. I get x is 5. Okay. Then the second one, remember I distributed this negative, so now I have a -x at minus 1. So I'm going to add this x to the other side. I get 4x minus 9 equals -1. Add the 9 to both sides. I get 4x equals 8. Divide both sides by 4. And x is 2. We now need to check these into the original. So the first one we're going to check is the 5. So I had absolute value of 3 times 5 minus 9. And then x again is 5. So up here, right here, we're also going to put in a 5 for x. So we get 3 times 5 is 15. 15 minus the 9 right there is going to give us a 6. The absolute value of 6 is 6. And then on this side, 5 plus 1 is 6. 6 does, in fact, equal 6. It's a true statement. And so we can go like this and say, yes, it's true. All right, let's try 2. So I'm going to plug 2 into the original. 3 times 2 minus 9 are inside. That's going to equal 2 plus 1 on this side. 3 times 2 is 6. 6 minus 9 is a -3. The absolute value, however, of -3 is +3. And then on this side, I have 2 plus 1, which is 3. They do match, and so both of these answers are true solutions. Your homework tonight is the other page. It is evens only. Thank you, and I'll see you later.